Now in this lecture we are going to learn another type of resolution technique, which is open addressing. So in open addressing, colliding elements are stored in other vacant buckets. During storage and lookup, these are found through so-called probing. So the first type of open addressing is linear probing. So in the linear probing, it places new key into closest following empty cell. So let's look at this example to understand it very clearly. So in this case, we have 3 strings over here, and we have used hash function to convert these 3 strings to the integer. Now based on these integer numbers, which are hash values, we can insert these strings to this hash table over here. Now here the first string is ABCD. So for ABCD we have got index of 2. So we are going to insert it at the index of 2. Now after insertion, we see that for the next string we have also the hash value, which is 2. So if we go to the index 2, we see that in the index 2 we have another string. So this means that we are going to continue to the closest following empty cell. So the closest following empty cell is 3. So we are going to insert this next string at the index of 3. Now for the next string, we see that one more time we have another hash value, which is 2 also. So here again we are going to check the index of 2. So we see that at the index of 2 we have another string. So we are going to continue to the next cell. So in the next cell we have another string. This means that we need to continue one more step further. So we are going to continue to the next cell. So in the next cell we see that this cell is empty. So we are going to insert this string to this cell over here. So that's how the logic behind linear probing works. So every time it's going to check the next cell to see that if it is empty or not. So if it is not empty, it's going to continue to the next cell. Otherwise, it's going to insert that string to the empty cell over here. Now, as we said before, in case of open addressing, when hash table becomes full, so in this case, we are going to create 2x number of new hash table, and we are going to move these strings to the new hash table, and we are going to continue from there. Now you might be interested that how can we decide when we are going to create new hash table? So in Java documentation, it mentions that it has to be decided based on load factor. So we are going to calculate load factor, and based on load factor, if it is greater than 0.75, in this case we are going to create new hash table. So with this, by using this number, we are keeping the performance of hash table in O runtime complexity. Now based on this logic over here, let's head over to Java and create a new class for linear probing. Now here I'm going to create a new file which will be called linear probing. So I'm going to add a new file, so it's going to be linear probing.java. So inside this file we are going to create our linear probing class. Now the first thing that I'm going to do, I'm going to import array list, because here we are going to use array list. So it's going to be imported using Java util library array list. Then I'm going to create our class like this. So it's going to be public class linear probing. Now inside this class, the first thing that I'm going to do, I'm going to create hash table. So in this case, hash table will be the type of string. And then we are going to create a new variable over here, which will be store the number of cells that used in hash table. So it's going to be like this: string hash table and integer used cell number. Now then inside constructor, we are going to initialize our hash table based on the parameter that we are receiving from user. So it's going to be like this: linear probing. So it will take as a parameter integer, will be the size. This will be the size of the hash table. Then we are going to initialize hash table like this: hash table is equal to new string, this size that we are receiving from parameter. Then we are going to set used number of cells to 0, because in this case we have not any element in our hash table, so the number of cells that are used is 0. Now after doing so, we are going to create hash function, because we need hash function to find the index. So in this case, the hash function that we are going to create over here is same as with the one that we have created in case of direct chaining. So there we were taking the ASCII values of characters, and then we are finding the mod of some of these ASCII values with the number of elements in the hash table. So here again we are going to use the same function, so I'm not going to create it from beginning, so I'm just going to pass it over here, that function. So basically this is how our function looks like. So in this case we are taking the ASCII values of each character that comes from this string, then we are summing up these ASCII values, and at the end we are finding the mod of this sum with the number of elements in the hash table. Now this is our hash function over here. Now after hash function, the next function that we are going to create is going to be get load factor. So get load factor will be calculated based on the number of cells that we have used over here and based on the hash table length. So after getting load factor, we are going to create another function which will be rehash function. So based on the load factor, we are going to do rehash or not. So let's go ahead and create load factor method. So it's going to be like this: public double. So it's going to return the double type of number, because in this case we are going to calculate it based on the number of cells and hash table length. So it's going to be like this: get load factor, and it's not taking any parameter. Then it's going to be like this: we are going to create a new variable over here which will be the type of double. So it's going to be load factor, and it will be calculated number of used cells multiply with 1.0 divided hash table length. Then at the end we are going to return this load factor over here. Basically this is a question that comes from the Java documentation, so we are just using it like this by calculating load factor, because every time when we are calculating the load factor, if it is greater than 0.75, in this case we need to create new hash table, because this affects the performance. So we need to have some extra empty cells in our hash tables to make our hash table to perform better. Now the next method that we are going to create will be rehash method. So in this case we are going to call this method for rehashing. So what does it mean, rehashing? So rehashing means that we are going to create a new hash table with the size of 2x, and we are going to insert all elements from the current hash table to the new hash table. So our hash table will be like this. So I'm just going to comment it over here like this: rehash. So here we are going to create it like this: public void rehash keys. So it's going to take as a parameter the string that we want to insert to the hash table. So it's going to be like this: string word. Now here the first thing that we are going to do, we are going to create a temporary array list, and we are going to insert all elements from the current hash table to the temporary array list. Then we are going to initialize this hash table with the length of 2x. Then we are going to move all data from the temporary array list to this hash table over here. So I'm going to create array list with the type of string. So it's going to be the data, and we are going to initialize it like this: new array list. Then we are going to move all elements from the hash table to this data over here. So it's going to be like this: for string s in hash table. So we are going to loop through the hash table and add all elements to this data array list over here. So it's going to be like this: if s is not equal to null, in this case we are going to add data add s. So we are moving all elements from hash table to this data structure. Then at the end we are going to add this word that comes from the parameter to this temporary data structure over here. So it's going to be like this: data dot add word. So this is the word that we want to insert. Now then, after doing so, we are going to initialize hash table with the new size. So hash table will be equal new string with the size of hash table length multiply with 2. As we said before, we are going to create it with the size of 2x. Now then, here with this we have successfully moved all elements to this data structure that we created over here. Then we have initialized our hash table with the size of 2x. So after initializing it, we are going to move all elements from this temporary data structure to this hash table over here. So here I'm going to write loop like this. So for string s in data, we are going to insert all elements to this hash table over here. Now how can we insert all elements to this hash table over here? So here we cannot insert it because we have not created our insert method in hash table in this case. So I'm just going to comment it insert in hash table. Now after this method we are going to create this insert method. So I'm going to call this insert method that we are going to create in this rehash function over here. Now here when we are calling insert in hash table method, we are going to increase user cells in hash table. So here when we are calling insert in a hash table, we are going to increase used cells by 1. So this means that when we are calling rehash key method, in this case first we need to set number of user cells to 0, because every time when we are calling the insert method it's going to increase by 1. So as we are initializing new hash table over here, we have to set this value to 0 initially. Now then, after this method we are going to create insert in hash table. So I'm going to put it like this. So the name of method will be insert in hash table. So I'm going to declare it like this: public void insert in hash table. So this method will take as a parameter string value. So it's going to be string word. Then we are going to implement the logic over here. So as we have created this function over here, we can easily call this function inside this loop over here inside rehash function. So it's going to be like this: insert in hash table with the parameter of s, because in this case it is inside loop, so it's going to be s. So with this we have successfully implemented rehash method over here, and then we are going to implement the logic for the insert in hash table. Now here, the first thing that we are going to do, we are going to get load factor. So based on load factor, we are going to call rehash function inside this function or not, because if load factor is greater than 0.75, we need to rehash this hash table. So in this case, we are going to call rehash keys method over here. So here I'm going to create a variable called load factor with the type of double, and we are going to assign the value that comes from get load factor to this variable over here. Now then we are going to check that if load factor is greater or equal to 0.75, so this is according to Java documentation, then in this case we are going to call rehash function. So I'm going to call rehash function for the word that we want to insert. So it's going to be word. Otherwise, we are going to insert this word to this hash table over here. So in this case, to insert a word to this hash table over here, in case of linear probing, first we are going to calculate the index, then we are going to check that if the current index is full, we are going to look for the next empty cell and we are going to insert the value over there. So here, the first thing that we are going to do, I'm going to create a variable called index. So it's going to be calculated based on the hash function over here. So we are going to call hash function for this string that we want to insert and hash table dot length. Now after doing so, we are going to loop through this index until the index plus hash table dot length, and to calculate new index and check that if this index is empty or not. So this is the logic that comes from the linear probing. So here we are going to write loop like this: for int I is equal to index, so starting from this index that we calculated using hash function, and it will continue until index plus hash table dot length, and in each step is going to be increased by 1. Then here we are going to calculate new index. So this new index will be calculated based on the mod function. So we are going to do it like this: I mod length of hash table. So this is giving the remainder from this division. Then we are going to check that if we have any value in this new index over here, we are going to look for the next value. Otherwise, we are going to insert it to this new index over here. So if hash table new index is equal to null, in this case we are going to do like this: hash table new index. In this case we are going to insert it to this index over here because it is empty. So I'm going to set it like this to word. Now after doing so, we can print out saying that successfully inserted. So I'm just going to put message system.out.print. So we can put that the word successfully inserted at location plus new index. Then after doing so, we need to call break because we have successfully inserted the node to this hash table over here. Now otherwise we are going to continue to loop. So in this case, I'm going to print out to the console that this new index is already acquired. We are trying next empty cell. So in this case, it's going to be like this: index is already occupied, trying next empty cell. Now after doing so, it's going to look for the next empty cell. Then at the end, after this loop, we are going to increase number of used cells by 1. So it's going to be like this: used cell number increased by 1. Now with this, we have successfully implemented our insert in hash table method. Now basically what we are doing over here is, first we are calculating load factor, then based on load factor, if it is greater than 0.75, in this case we are calling the hash keys method. Otherwise, if the load factor is less than the 0.75, in this case we are going to calculate the index and we are going to insert this word based on this index to this hash table over here. We have implemented linear probing logic over here in which it checks for the next empty cell over here. Now at the end, we are increasing used cell number by 1. Now before looking how this is working in practice, so as you remember in our previous lecture, when we are implementing direct chaining, we have implemented a method which prints out the hash table to the console. So I'm just going to copy that method over here to see the result after insertion. Now this is how our method looks like. Basically what we are doing over here is we are just looping through the hash table and printing out their values to the console. Now let's see how this is working in practice. Now before running these methods in practice, I've noticed that we have some typo error over here. So when we are initializing hash table, we have put bracket over here. Instead of bracket, it should be square bracket because we are initializing the string type of array with this size over here. Now then inside insert in hash table, when we are calculating new index, it should be calculated based on the hash table's length. So it's going to be imod hash table dot length. So it's going to be calculated like this. Now after doing so, inside main class, we are going to create the instance of linear probing. So it's going to be like this, linear probing, and I'm going to initialize new linear probing class with the size of 13. So as you remember, in case of direct chaining, we were inserting these words to the hash table. So we have noticed that in case of quick and fox words, in this case, they are causing collisions. So in case of direct chaining, we were inserting them in the same linked list over here. But in case of linear probing, after inserting quick, the next word, which is fox, that causes the collision over here, will be inserted to the next empty cell over here. Now if I run our code, you see that in the console, first it says that the D, which is this one, the article, is inserted at the location of 3. Then the quick successfully inserted at location of 8. Then the word brown is inserted at the location of 6. Now when it comes to fox, it's calculated that the index is 8, and it says that 8 is already occupied. We are trying to next empty cell. Then the next empty cell is the index of 9, so that's why fox inserted at the index of 9. Then the last word, which is over, is inserted at the index of 2 over here. Now if we look at our hash table over here, we see that all words are inserted to this hash table over here. So here you can easily see that for quick and fox is calculated the index of 8. So 8 was occupied after quick inserted over here. Then it is inserted at the next empty cell, as we discussed in case of linear probing. So the logic behind the linear probing is implemented over here successfully. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented linear probing with insertion method. Now in the next lecture, let's implement search method and delete method in case of linear probing. So see you in the next lecture.